Hi everyone, Madhav here. This is the last beginner 0 to ML workshop. Today we're going to be learning Python, and after this, it's just ML libraries from here on out. So hopefully you're excited for that. In today's workshop, we'll be using Kaggle.com. It's a very easy way to run Python code online, so you don't have to worry about setup. Just go to Kaggle.com. The link is in the description and register if you don't have an account, or sign in if you do. You can sign in via Google. After that, go in the description and go to this link, click on copy and edit, and you'll be good to get started. And it's just that simple. So pause the video. Hopefully you've done it. I'm going to tell you what we're doing today. So we are going to do a bit of a Python speedrun, and there is a bunch to get through. However, I do have a consolation for you. I created a bunch of fun visual exercises that I'll bribe you with as we go throughout so that you don't get too bored. Um, Anyways, to get started, go to this first Python Basics 1. Link is in the description. Click on copy and edit. I'm going to open it up here. Here we are. So we're going to learn about some very simple stuff, the very basics of Python first. Now, if you've never programmed before, I should note a couple of things. Let's say we go to any, site, like let's say we go to youtube.com. Well, when we go to the site, let's say it says try searching to get started. Let's say I search for fluffy kittens. Well, YouTube, after I search something, it's going to store what I just had. And if I wanted to, search that again, it has stored some data, so it knows what to recommend next. It has aggregated this data across lots of users so that it can give me good autocomplete recommendations. If I signed in, it would have a search history so that, it would know, okay, you've sought out these things in the past, maybe I want to recommend these videos to you in the future. The point I'm trying to get at is it captures data about you and then transforms that data. So for example, my search, it's just some text, but it can, let's say, add things onto that text, manipulate it so that it can give me autofill recommendations. It can store that text, store that data, and then when I next log in, it might give me a search history. So this is what all programming languages are designed to do. They will store different kinds of data, not just, let's say, text, but also, for instance, numbers, like the number of views on a video, or dates, like when a video was created, and so on and so on. They store all sorts of data. They modify it in ways like, adding on things. So let's say combining two pieces of text, or when someone watches a video, making the view count, go up by one, so increasing a number, and so on and so on. So this is what we're going to start by learning about in Python. What kind of data types can we store, and what can we do with those data types? How can we modify them? How can we use them to do useful computations? So let's get started. I'm going to speedrun this a little bit, so feel free to pause and read through the annotations on the video. Sorry, on the notebook. The notebook is what you can run code in. First off, here in this notebook environment, you can click on these play buttons next to any cell, and it will tell you, okay, it's like getting ready to execute code up in this top corner here. And whenever it's ready, this thing will stop spinning and you'll see the output of the code beneath these code cells. That's what we call them. Anyways, side note aside, first thing about Python, we can just write in text. Let's say we want to explain what we're doing. We can have multi-line text, multi-line comments if we have three quotation marks. So those can be the single apostrophes or the triple apostrophes. And, whatever is between those, it counts as a comment. It's not actual Python code. It's not going to do anything. It's just so that other people reading your code, they're familiar with what's going on. As we talked about, there are data types. So for example, let's say we want to store the name of a video, the text. We will use a string data type, fancy word for just text. We also have numbers of various sorts, like integer numbers or decimal numbers, which are called floats. We can have true or false values, and we can even combine multiple pieces of data. Let's say we can combine them in a list or in a tuple, where, this thing, I can easily add things onto the end of the list, for example. So I could add on like a number 4 easily, and this thing I cannot. Finally, one last common data type to know about is a dictionary. A dictionary is like, a real, phone book or a dictionary. You look up a name, like a word, and it will tell you a piece of data. So in a dictionary, you would look up a word like, flabbergasted, and it will tell you some piece of text related to what does that word mean. In this case, you have a key, any text, being mapped to anything. It doesn't have to be, some text or a definition. It could just be like a number or, a true false value or something else. Finally, this is like a placeholder for there's nothing here. Hopefully that makes some sense. Then we talked about on YouTube, you don't want to just have some data. We want to combine different pieces of data. To do that, we need what we call operators. They take different pieces of data and, modify them. So you could, let's say, combine two pieces of text together. You could make a number smaller or larger. You could change a true to a false or vice versa. You could add things on to a list or remove things from a list. Anyways, to just speed run through a few operators, the math operators are pretty obvious. Whatever you'd expect in math is what happens here. There are some complicated operators that are a little bit strange. For example, doing a division and just getting, the non-decimal portion or getting the remainder of a division. But for the most part, pretty straightforward. I can even run these things, so I can run this cell, and you will see you get what you expect. By the way, I'm using this built-in tool in Python, a function. It's very much like the command line, the tools that we learned about in the very first session, except, of course, instead of calling, let's say, an echo command just once, I can combine lots of different pieces of code, and when I run them, all of them will execute one after the other. So more convenient. Here we have some other operators for pieces of text and also lists. They behave kind of similarly to how you'd expect. So you can copy things a bunch with the multiplication operators, and then you can squish things together, add them together with the plus sign, which here is given the fancy name concatenation. Some Boolean or true or false operators. Again, you can, take a look at these. They're more or less straightforward, with the one exception of this exclamation mark. In programming, exclamation marks usually mean not. So when I say cat is not equal to dog, well, that's how I would read it. That would be exclamation mark equals, not equals. So because cat and dog are, well, clearly not the same pieces of text, we get back true. All right, next we talked about how we wanted to store some operators, so some, store some pieces of data. So for instance, we could, let's say, assign some names to two values. So let's say we assign some names to these true and true values. And then we can apply another operator, so the AND operator, on these two Boolean values. This is a little bit like Control F. So if I wanted to figure out what Sunny was, well, I Control F, I see Sunny is equal to true. So it's like I wrote true here. I can reuse a variable throughout my code. So if I run this, sunny and warm, because these are true and true, returns true. But if I set this variable to a different value, then if I run this again, you see I get back false because, true and false, one of those things is not true. So, we get back false. This does give you a headache sometimes if you're newer to coding, so maybe pause the video, review it here. Anyways, I did promise we're not just gonna go old theory. Let me do some fun stuff with you guys. So I've created a bunch of programming exercises here. Don't worry, don't be scared by all of the code because we are going to do some just, little to-dos, and then the rest of the code we can simply just run. Again, I've posted the link to this notebook in the description. Just open that up in the same way that you opened up the basics notebook, and you can follow along with the exercises as I do them. So while I wait for this to start, the very first exercise is very, very simple. We're just learning about, variables. So that's the first exercise. All we need to do is fill in a couple of variables. So the first thing is I'm being asked to fill in my name. Well, my name is Malav, so I'm gonna fill that in. I use those double quotes for text. I want to create a string data type because a name is a piece of text. Now my birth month, I'm being asked to put in a number, so I can put in some number. For instance, let's say I'm born in January. If I were, then I would put in 1. Finally, I'm being asked to put one last number, a favorite number between 1 and 10. Let's pick, I don't know, I'm feeling in the mood for 3 today. So that's kind of our very first very simple exercise. We created some variables. If I click on run, then, it will run. And the only other thing is I have a bunch of complicated code here. Over time, you'll learn what this does, but for now, you just click on run, and you'll see that I get a little a color palette generated for me based on the stuff I put in. So let's say I wasn't feeling the number 3, maybe I wanted 6 instead. I can run this here by clicking on this, and again, run this. I'm also able to use a keyboard shortcut, Control Enter. It does the same thing as clicking on these things. Anyways, you can see I get back different results. And one last time, let's say I was born in February. So run that. And then here. Hmm. It didn't seem to change all that much. I guess well, let's see. Maybe I'm an Alex instead. Let's see if it changes more. That's a bigger change. Okay. Anyways, so the thing we're doing here is we're assigning some variables here, and whatever the complicated code here is doing, it's reusing the values we assigned. Exactly the point of assigning variables. Okay, now let's learn a few more things and then we'll go back to do another fun exercise. So the next thing is we got to learn that this is convenient and all. We can assign some values, use them later in the program. We can even modify things. So, I'm taking my age 20 and then modifying it later on in the program. There are some naming guidelines that you can read through if you want, whatever. Next, let's learn about functions. So functions are like the command line tools. We already talked about the print function. So this is built into Python. It is like the echo command line tool that we learned about. And when we call it, it clearly prints some stuff for us to take a look at. But there are lots of other functions built into Python that we can use. For example, here are some math functions. There's a sum, max, min, and if you pass in a list of numbers, then it will, add them all together, give you the max number, give you the min number, or here, give you how many numbers there are. So what is the length of this list of things? So for example, I run it and you can see I can get the sum of all of these, or max, min, length. Keep in mind, a string, so a piece of text, is like a list of characters. So usually, you'll have equivalents of these math functions on lists of numbers that convert to lists of other things, like, this list of characters. So the length function also works on, let's say, a string. One thing to keep in mind, we have a few functions that we're going to be using a lot that converts from one data type to another. Again, data type, just a fancy way to say, do we have text? Do we have integers or decimals or true or false values, whatever. Whenever we want to use an operator, well, just like we can't add apples and oranges, we can't, let's say, add 5 and apples, because this is a number and this is some text. So whenever we do that, we'd get an error. If we want to be able to combine different pieces of data together, we have to first convert from, let's say, a text to a piece of number, or some number to a piece of text. So when we call this in, what we call this in, actual programming is casting. So we have these built-in functions to, let's say, convert this number age to a string. And then, as you recall, we learned about the plus operator, which can squish together, concatenate different strings. So for instance, if I don't have this, well, right now I'm trying to concatenate, squish together a number with some text. If I run this, you'll see I get an error, because that doesn't make sense. How can you add up a number with some text? But if I convert this with the string function, then I can indeed convert the 25, the number, to a piece of text, and then, concatenate it all together. This is a very common thing to struggle with for beginners, so I'd suggest you pause the video and review these other examples here. Now, the last functions that I'll talk about that are built into Python are for, groups of data, because often if you imagine a site like YouTube, you have groups of things. You don't have just one piece of text. You may have, 15 videos that you want to return back. If you're often getting lists or dictionaries or, groups of data, here are a few common methods. So the append method adds something on to the end of a list. So let's say I want to add orange after cherry. Then I can press this. I can, press the play button or control and enter. You can see the original list I'm printing here. And after I add orange, well, orange has added it onto the list. One thing I want to mention, so for whatever reason in Python, we start counting at 0. So this is, you would say in English, the first element of the list, but in Python, we say it's the 0th element of the list. And this is the first, and this is the second. I don't know, programmers are weird. What can we do? Anyways, let's say you wanted to insert a number, or let's say a piece of text, into the first position, and I just told you this is the 0th, this is the first. Well, if I want to insert mango after this first element, banana, then I can use this insert function that's also built in, and you can see where there used to be a banana, there is now a mango. So that first position, 0th and first, the first position has this new piece of text inserted in there. Finally, there's a pop method. It takes the last element from the end out of the list, and you can see I'm left with this list after I pop from this one. You can also get specific elements, that's what we call each item in the list, using this syntax where you have these square braces located near your enter key, and you can, say, okay, I want the 0th element of the list, which will be red, or I want the, first, second, which will be blue. You can also work backwards, so, -1 means the first element from the end, -2 means the second element from the end, and so on. Last thing that I'll mention here, we can also get a range of elements. So this syntax, maybe it's a little bit inconvenient, but it says start at the 0th element, then go up and stop before you get to the 3rd element. So 0, 1, 2, 3. So this would take in these elements. Start at the 0th, stop before the 3rd. If I run it, you can see I get the first 3 numbers. You can omit one of the ends. So let's say I decided to omit this ending number. That just means start at 0, 1, 2, 3. So start at the work 3 elements back from the end of the list and keep going until you can't anymore. So if I do that, then I get the last 3 numbers. There's also a weird thingy here where you can skip, items. So for example, if I use this syntax, what this translates to is go from the first element to the very last element. So those are inferred. And then between elements, add 2 each time. So start here, then instead of adding 1 and moving here, add 2. So start here, add 2, get here, add 2, get here, add 2, and so on. And that's what you can see we have here. We get the even numbers like this. Let's say I wanted to get the odd numbers, then I could start at 1 and then add 2 each time. So let's say I start at 1, add 2 each time, you can see I get the odd numbers. This can be confusing. I think it's been a long time since I learned this, but I bet you I'd have found this confusing. So take a moment, stop here, maybe reflect, and when you're ready, we'll go back to the visual exercises to have something more fun. So second exercise, we're going to work with lists. It's asking us to choose 4 different emojis, and they have to be pieces of text because there is no emoji data type in Python, unfortunately. So let's say we have a rocket emoji, and I'm also feeling like a test tube. How about some kind of animal? Let's say a cheetah. We don't have a cheetah. How about a lion? And maybe we'll finally do, let's say I have a seal here. Seal seems good enough. Then it says, okay, I have a dictionary here. It maps some kind of key to a definition of, what kind of pattern will be created with that key. So let's say I pick the checkerboard pattern. So again, I press Control Enter, or you can press the play button here to run that. Some complicated stuff here, but if we ignore it and run it, we can see we have a checkerboard. Let's try a spiral instead. And run this. Okay, cool, we get a spiral. And let's do one last one. Let's say I want to do a diamond. Let's see what we get here. I do indeed get a diamond. So that's kind of cool. I think we are also ready to do this second one. This one's really cool. So this one is going to generate a musical tone, one that you can actually play. The only problem is we haven't yet defined functions. So we're going to learn functions and then come back here. Okay, so we've learned a lot about lists here. We learned about some built-in functions built into Python. So like the max or min function that can take in, a bunch of numbers, and then they can return something like, what is the sum of those numbers? That's the general format of a function. It will have some kind of name, like a sum. That's the name of the function. It takes in some data, so a list of numbers, and then it returns a single number in this case. Well, what if we don't want to rely on functions that, people have pre-built for us? What if we want to create our own functions? First of all, why would you want to do that? Well, it's to reuse code. Let's say I go back to the YouTube example. YouTube is not gonna, write some, let's say 5 lines of code every time they want to update the view count on a video. They'll just have a single function that does that. They won't have, 100 lines of code every time someone wants to subscribe to a YouTube channel. They're just going to have one function, and everyone who wants to subscribe can use that function. So functions are ways for us to reuse code, share functionality. Again, key parts of functions: what's the name, what input are you taking in, and what are you returning back. That is the syntax for functions that you want to define as well. So you use the def keyword because you want to define a function. You tell the name of the function that you want to define, and you write what kind of input you want. Then you can put in whatever lines of code you want to reuse inside the function, and you say also what the function ought to return. So in this case, the function is going to take in the name, which has to be a string so that it can be concatenated with hello. And then we return, whatever we stored in this variable. So, the result of squishing together these strings. So this function, it takes in a string and it gives back a string. Here you can see me calling the function or using the function. So I put in the function name and then I specify, what I want to pass in. It will return something which I store in this variable, and then I print the variable. If I run this, you can see I get back hello Alice. Let's say I change back, what I'm passing into the function, I'll get a different output because change this, change this, change this, change this, change this, and finally change this. That's a lot of change this is. This hopefully seems similar to you compared to, let's say I had numbers 1, 2, 3, and then I was getting a sum of the numbers, like the result is the sum of numbers. So I'm still doing the same thing. The only change is I have to define the function before I'm able to use it because Python doesn't have a built-in function like this. Keep in mind that you can have multiple parameters. That's what these inputs are called. So for example, let's say I want to create a function to calculate how much I want to pay at a restaurant. Well, I need to know, what is the base bill and how much am I tipping as a percent. Then to find the amount that I'm tipping as a dollar, I can multiply whatever the bill is by the tip percent. But since this is as a percentage, I need to divide by 100 to get rid of the extra factor. For example, if I have 60, I don't want to pay, 60 times the bill amount. If I want to tip 60%, I want to actually tip, 60 divided by 100, so 0.6 times more. Finally, to get the total amount that I need to pay, I add together the tip and the, base bill amount, and finally I return. Here's what you need to pay in total. So you can see here I'm setting some values to some variables. So my bill is $45. I need to pay 18% tip. I call the function by passing in these input variables. I get the result back, and then I'm printing it with this fancy syntax. Now this syntax looks fancy. All it does is it makes it easy for me to convert numbers to strings. So the alternative would be like this: bill, dollar sign, and then I do a plus sign, then I do string, dinner bill, then I do another plus sign, then this. I'm sure you can agree with me this is very ugly, but it's doing the exact same thing. Total, dollar sign, and one last one, string total cost. So these two lines are equivalent. This one is just a whole lot uglier. This syntax where you put an F at the start of your quotation marks, and then you put these braces, curly braces, again next to your enter key, around any variable. This automatically converts whatever you have here into a string. The good part is you can have any Python in here. So for example, I could do, dinner bill plus 10 for whatever reason, and it will change the results. So whatever you have in between the curly brackets, eventually it will get converted to a string. Okay, these are called f-strings if you want to search them up. search app f strings. Cool. So now we know how we can create our basic functions. We know the syntax where we put in the name and some inputs and what we return. We also know the actual functions can have multiple inputs, and sometimes they don't even need to have a return statement. So for example, this function, I'm passing in a few items, and I am just printing those items out in a shopping list. I'm not even returning anything. Again, the key idea to keep in mind, these help us reuse code. That's why we like functions. So now what I'd encourage you to do is pause the video. These are a few functions that you can fill out. I've left in some comments. These are good practice. This is called doc strings, basically, documentation strings. They tell you about the inputs to the functions and what they're expected to return. And they can give you, some hints as to the types of different variables. So this strange colon and then data type syntax, it doesn't do anything different. Neither does this arrow do anything different. They're just type hints, just hinting to you. Hey, this is a piece of text, by the way. Just thought you'd want to know. Give it a pause, try it out, see if you're confused. Okay, so assuming that you've tried it out, I'm going to walk you through the solution. So this first function, it's asking us to create a dictionary containing the person's information. It wants us to use these keys. So that's what I'm going to do. I'm going to create a person dict because that's what I need to return. I'm going to create a dictionary. It can, be across multiple lines. It doesn't matter. It says use the key name. Well, I assume that's going to map to the variable name. It says use the key age. I assume that's going to map to the variable age. And finally, use the key hobbies. Assume that's going to map to the hobbies list. So that's that done. Next it says print a nicely formatted display of the person's information. They want it to look like this. All right, well, I can do that. And as this function is telling me, I don't need to return anything. So just a bunch of print statements here. I can access the person dict. It will be passed into me. I was already told that it has these keys in it, so that's what I'm going to use. So for instance, I could do name, and then I could do plus person dict as name. Alternatively, I could use f strings, so f and then the quotation marks. Then I could do age, and then person dict at age to access what is the person's age based on what was passed in to the function. So I want to put in age, years old. Finally, I want to print out some hobbies, so I can do hobbies plus string person dict at hobbies. And I know I can access hobbies because, that's what the doctrine said the key would be called. So that's that function done. Finally, it says add a new hobby to the person's list. It says I don't have to return anything. The reason for this is that when you modify a dict, it's modified everywhere, not just, within this function. Whereas most variables, like let's say this tip and total, I can't, let's say, print tip outside here because this variable, it's part of this function. Like it doesn't exist out here outside the function. On a similar note, you do need these indents. That's how you separate code that's inside versus outside functions in Python. Anyways, if I run this code, you should see, nothing's defined. It says tip is not defined because literally I have no variable called tip outside of this function. It's only inside this function that it exists. Anyways, back to here. Dict, or yeah, so a dict is not like that. Whatever you modify inside the function is also going to exist outside the function. So if I change something in dict here, let's say I take person dict, I access the hobbies. I can take a look here, and I know this is a list, right? It's a list. I know to add on to a list, let's say hobbies list equals that. I can do hobbies list dot append, and then I can put in the new hobby, and that's it. If I wanted to, I could combine these two lines. So, this gets a list from the dictionary, and then I can also append directly like this. So it's like I'm calling this function on what is implicitly a list, even without accessing this variable. Anyways, with that done, here are a few lines of code to test. So I can create person info. It will create a dictionary using this function. Then I can print out the person's info, add a hobby, and then print out the person's info again. So at the start, I get this info for the person. After I add a hobby, swimming, or actually cooking, then you can see a new hobby has been added. The last thing I'm going to do in this video is let's finish this cool little exercise. So here we have to create a different function. We're given a specification, which is a string, so a piece of text. It has this special format where we have three numbers. First, the frequency of a sound, then its amplitude, and finally its duration. So what do we do with this? Well, it wants us to first split this string. So we're going to get a piece of text that's going to look like this into the three components. And it gives us a hint that we can use this method. Then it wants us to return, these components that we split up as numbers. Just so that you're comfortable with what the split function does, let's say I run this piece of code. So you can see I have a list of numbers, 1, 2, 3. Once I split them, I get a list. So let me print out the list. And you can see I have 1, 2, and 3 because I split these things up by the dashes. Then I can unpack the list. So I can, access the first element, the 0th element in programming, or, this element or this element. And I can print those out individually. So the code here, it looks pretty similar, with the only exception being that, these things, when I split them, because I split up a string, a piece of text, the chunks remaining are also pieces of text. So what's going to happen here is I'm going to get the split components. So let's call it parts. It's going to be specification, that's the inputs, string. Then I call the dot split method. I want to split by dashes, so I want to split these dashes up. Next, I need to unpack the string into frequency, amplitude, and duration. I'm told frequency first, then amplitude, then duration. So frequency equals parts at 0, amplitude equals parts at 1, and finally duration equals parts at 2. Now the last thing that says is return the frequency, amplitude, and duration as numbers. Well, remember, this just means we need to do our casting. We need to convert these strings into numbers. The other thing to keep in mind is we can literally just return, multiple values with commas. So we can do return, frequency, amplitude, duration with commas, and it will return multiple things. Just keep in mind right now these are strings, so we got to convert them to numbers. So frequency, it needs to be an integer number, so I do int. Amplitude, it needs to be a decimal number, so I do float. And finally, duration is another integer, so I do int. Now keep in mind, I could have been a lot more concise with this. One thing to note is instead of unpacking a list like this, unpacking meaning, accessing the different elements, Python has this equivalent syntax. It does the same thing. So this automatically assigns the first So the zeroth element to this variable, the first element to this variable, the second element to this variable. So this and this are all equivalent. Anyways, with that said, I only have one more to do, where it wants me to try, creating my own frequency, so my own specification for different audio. So what I'm gonna do is, let's say I try, let's try 900 hertz at, let's try a higher volume, 0.7 for 3 seconds. Now I'm gonna run this code. Remember, I've defined a function, so this, it will be able to call it here, define some variables, which some fancy code over here will use. Again, I can run this. And what I see is I can visualize sound waves. So you can see this is at 440 hertz, so, lower frequency sound wave, 900 hertz, over twice as much frequency. You can see the amplitude of the sound has also changed. But better than actually visualizing the sounds, you can even listen to the sounds. Unfortunately, this doesn't seem to work online, so just right click here and download, and then you should be able to play the sounds on your computers. Anyways, with that, I will call it a day for the first notebook, which is on the basics of Python. Next up, we're going to learn about some more advanced features.